Hi, everyone. Thanks for joining us today, and welcome to Data and AI Summit. My name is Kian Shahab. I'm a solutions architect at Databricks, and I'll be our moderator for today. So I'm really excited for today's session. It'll be led by Dillon Bostwick. He's a senior solutions architect at Databricks based in New York, and he's been at Databricks for 5 years now. So I'll let Dillon, go ahead, and at the end, we'll be taking some live questions, and I'll be walking around with the mic in case anybody has a question. Just raise your hand. Thank you.
Hey, guys. Wow, what a great turnout. Excuse me. What a great turnout today. I'm super fortunate to have everyone's attention before, everyone's brain has turned into a mush of LLMs and Gen AI and Lakehouse. So let's get started. Just a quick housekeeping note, for some of you guys who may have signed up for this, a couple weeks ago, it was called Data Quality Fast and Slow. We made a slight change. If you are interested in data quality, we will be talking about that in a couple of different capacities and how it relates to what I'm calling fast and slow. But if you also want to learn more about data quality and how it relates to the Databricks product, we will also be making some pretty exciting announcements tomorrow morning at the keynote, as well as in some of the afternoon deep dive sessions. So definitely check that out as well. So a bit of background about me. I'm Dillon. I have been with Databricks for a little over 5 years. And I basically spent that entire time working directly with customers. So I've been super fortunate to get to work with a lot of different kinds of accounts, ranging from digital native, data and AI, very forward startups to Fortune 50 and above companies who are also embracing data and AI. So what I've been really interested and excited about, especially recently, is taking some of the general patterns and trends and recurring themes that I've seen across all of the different accounts that I've worked on at Databricks and try and distill those into things that you can learn from to kind of help prevent potential mistakes and learn from some of those things. Particularly, I spend a lot of time when I'm not working directly with accounts getting pulled into things around the data transformation, ingestion, and streaming side of the Databricks products, so things like Delta Live Tables, Autoloader, and I help lead a group of folks around the world who are experts in Delta Live Tables. So what I'm really interested in is this notion that, I think a lot of people, when they think about streaming, right, just generally, we're going to get into semantics and talk about some of those preconceived notions in a little bit, but a lot of people think streaming and they immediately think, oh, that's a way to take data from point A to point D at a really low latency, maybe on the scale of milliseconds. Well, it turns out there's actually all sorts of reasons why streaming can add a lot of benefit, even if it's actually not at a really fast latency. And that's kind of what I've been really interested in recently. My friend Avi and I, just a couple of weeks ago, we gave a talk at ODSC London about applying streaming to real-time machine learning. Even if you don't need really low latency, there's actually some implications there. So the first thing I want to state is this is probably where most people think about when they hear streaming, right? You've probably been pitched this before at some point, or you've read about this from other thought leaders, this idea that the world's data is real time, right? And that's obviously true. It's actually a tautology if you think about it, right? Like that's the literal definition of real time, is that it's happening in the world in real time, right? But when we use that term in the industry, usually what we're talking about is this idea that maybe a couple decades ago, if you live in a city that's primarily car-based, you were probably going to Blockbuster Video, picking up a VHS. On your way home, you're going to stop by a bank, you're going to put a check in a little pneumatic tube, and it's going to get sucked up. And usually the way those banks would work, and those kinds of companies a couple of decades ago, excuse me, is they would have some sort of data warehouse or something that was designed to scoop up all of the orders from the operational system, usually at the end of the day or at the end of the week. They'll do some ETL, and if everything works successfully, you'll see a report the next day, and maybe a decision maker can make some sort of decision based on that report, right? And usually that was good enough for the data warehouses back then. Contrast that with today. Nowadays, I want to be able to log into an app, right, like my mobile banking app. I might want to apply for a loan, and within maybe a minute, I want to see if I'm approved, right? And now I'm very impatient because I'm constantly scrolling on my phone, and if I don't get a result in a minute, maybe I'm going to go download some other app. Maybe I'm not personally taking out loans that often, but I am pretty impatient when it comes to these things nowadays. And if I get denied for the loan, maybe I want to see some sort of next best action based on some sort of machine learning model, right? Another example, instead of going to Blockbuster, I'm going to log into Netflix or Disney Plus or something like that. I'm going to watch a movie, and when I'm finished with the movie, About an hour later, I already want to get some recommendations based on the movie I just watched, combined with maybe some of my viewing habits over the last week, right? And that's recommendation on the order of maybe about an hour or so, maybe less. But we can take a more extreme version of that, and we can also look at reels, right? So nowadays, I might go on my phone, I might watch a 30-second clip, and maybe that's like some TikTok video of some child prodigy doing some really cool, musician or something like that. And then when I swipe, I immediately expect the app to show me more of that because maybe I spent a second longer watching that video as opposed to some video of a cute dog, right? And say what you will about the societal implications of how addictive that is. It's really, really interesting when you think how it's able to figure out what you want better than you know yourself on the order of seconds, right? So TikTok, the public markets have decided they're worth over $200 billion because of their stickiness, right? They're able to position more ads because of how addictive that is. But the way that they're doing it is they're able to do, real-time scoring. So every second, they're actually rescoring their recommendation system based on the user data that's coming in some sort of stream. And not only are they doing real-time scoring, they're also doing real-time training in response to drift. And drift is something that we're going to talk a little bit and how that relates to data quality in a little bit. But just to give you an example of that, say all of a sudden millions of people around the world all want to learn about submersibles that are visiting the Titanic. Now, the model's actually going to retrain in response to that change in features that is probably indicating some new relationships between the features and the labels, right? So that's kind of like the extreme example. Not a lot of people are actually doing that in production today. But you can also look at what we consider more kind of traditional real-time use cases. So all the examples I just gave were more digital transformation, right? Ad companies, media companies, banking companies that are making that shift to what we're calling quote unquote real time. But you can also think of kind of the traditional streaming use cases like IoT, smart factory, real-time bidding, right? You usually have about 200 milliseconds to decide how much you're going to spend on an ad if you're a brand when someone clicks on a web page. And the really extreme example I always like to give where milliseconds aren't even good enough is what some hedge funds are doing, right? And so, again, societal implications aside, just appreciating this as a technologist, right? I find this really interesting, is, they're usually thinking about microseconds, maybe nanoseconds. And the story I always like to give here is there's actually regulations around how long the cable can be cut between the stock market server and the hedge fund server. Because if a hedge fund is smart and they become friends with the person who's cutting the length of that Ethernet cable, and then maybe they tip them a little bit of money, if they're able to shave a couple feet off that Ethernet cable, now they can see the stocks a nanosecond before everyone else, and that can equate to billions of dollars, right? Obviously, we don't need to worry about that for now, but I think it's a really interesting story, and it sort of paints this picture that every single use case that everyone here is working on, when you go back to work on Friday or on Monday, and you're trying to think about these use cases to put into production, whether it's a dashboard or a machine learning model, whatever it is, it sits on a continuous spectrum of desired data freshness. And this is very business context specific, right? I put use cases up there as examples, but there's actually some movement between there, right? And the reason I give the Ethernet cable example is because on one end we have nanoseconds, and then on the other end we go towards what I consider the OG consumer analytics use case, which is that every 3 months someone will send you something in the mail and ask you which TV shows you like to watch, for example. And what we end up seeing here is, so all of the latency is sitting on this sort of this desired data freshness spectrum that I call it. And usually what we do conventionally is we have this dichotomy between batch and streaming. And then usually we'll draw a line, maybe it's like 15 minutes, maybe it's 1 hour, depending on the data volume, depending on your background. And you're going to say everything to the right of that line is what we're going to call batch, and everything to the left of that line is this niche, complex thing called streaming. And even really experienced data engineers sometimes say, oh, streaming, that's like this complex thing. It's a whole new set of requirements. That's too difficult. Let's not deal with that right now. So what we end up doing is we say, well, everything that was traditionally batch, let's just stick that in the existing ETL platform. Let's just use the data warehouses that we've used since the 90s and the 80s in the days of pneumatic tubes and Blockbuster. And that's going to be good enough for now. And the point that I really want to make in this talk is that this is actually a false dichotomy. So we're going to talk a little bit about why technically that's actually not true. Batch and streaming are actually two sides of the same coin. And we're going to talk about some of the semantics around that in a little bit. But the other thing I think it does is it actually sort of hurts your agility and performance as a business, right? Because it makes it a lot harder to move across that spectrum. And what we actually find in reality is that it's not so much that I can support streaming or that I can support batch. What we really want is the ability to move across that spectrum. And then you have that middle area where it's like multiple seconds, maybe a couple of minutes. And that's that gray area. Sometimes we call it near real time. So the hardcore hedge fund people who are doing true real time, they say, oh, a couple seconds, that's near real time. And it usually has like this negative connotation. But I actually think the opposite is true. I actually think there's a lot of value that a lot of different companies and a lot of different data teams can get from playing in that middle area. And when we have this false dichotomy between batch and streaming, we start to ignore that area. So let me give a quick story just to illustrate that point. In case it's not obvious to you, why is he talking about being able to move across that spectrum? Don't you see the use cases are in kind of one little box at a time, which is kind of how we usually think about it. So say, for example, I'm a data engineer, and I'm working at a big brick and mortar retailer, okay? And I'm really excited. I'm hoping to get this promotion soon. So I put together this ETL pipeline, and I take all of my different data sources, and I build my ETL pipeline using Databricks or whatever it is, and I put together my sales forecast dashboard. And that updates about once a week. And I give it to my CEO. And they're really excited because they finally have some good analytics platform, and I'm hoping I'm finally going to get that big promotion I've been looking forward to. And then the CEO says, Dillon, did you really think that you were just going to see the sales forecast at the end of the week? Can you just, excuse me, can you just update that to every day, right? So the CEO is thinking, oh, I have this knob that I can dial. Let me just dial that latency expectation knob from weeks down to days. I'm saying, no, it's not that easy, Mr. and Mrs. CEO. There's actually some work I have to do. I have to change some scheduling rules. I have to change my partition size, and that might take a couple of weeks to test it, push it all into production. Okay, and the CEO says, well, we actually need that pretty quickly, like weekly, say it's Black Friday, for example, and the board's breathing down my throat about, getting an up-to-date forecast. Like weekly isn't cut it anymore in this day and age. So I finished that. I finally pushed the changes into production. The CEO says, I don't know what took you so long. I don't know why you didn't just dial the knob. But if you can do that, let's actually go ahead and make it update every minute. Now I'm freaking out, right? Because I don't have a knob. Going from weeks to days, as we know as data engineers, going from weeks to days is not the same process as going from days to minutes. So I'm saying, Mr. and Mrs. CEO, why do you need every minute? Well, say, for example, COVID just hit. And now all of a sudden we need to do this fancy thing called BOPUS, which is buy online, pick up, and store. It's a fancy way of saying curbside pickup, which is how most of us know it. And the only way we're going to do curbside pickup is if we have on-the-shelf availability down to the minute, right? Because people are going to put things in their cart, they're not going to see it, they're going to churn, they're going to go down to the other customer. And we need this today because everyone is going to go shop at our competitor if we can't do this. Well, I'm saying, no, that's not how that works, right? So, I have to take my point of sale data. Right now it's the transaction log at the end of the day. I have to see the real-time stream. I have to bring in a change data capture tool to handle the updates and deletes. I have to support SED type 2. The ERP system doesn't even have change data, right? True story, by the way. You actually have to do snapshot replication. That's a whole other mess. We have to support upserts. So I'm going to actually have to physically migrate the entire data platform into something that supports streaming and something that supports incrementalism, right? So the ability to incrementally update data as it's coming in. That's the only way we're going to hit minutes. And realistically, right, when we really think about this at a large enterprise setting, that could take years, right? Because we're physically moving data to a different cloud platform. We're physically supporting new things. We're bringing in change data capture tools. We're doing deals with new vendors to support all that. And all that time in those years, we could be losing millions of dollars to our competitors, right? So let me ask you this. At any point did the CEO say, I want real time, I want streaming? No, they didn't say that at all. All they said is, I want data at the right time based on the business needs, based on the situation that the business is dealing with right now, okay? So this is this idea, I like to think of it as right-time processing. I'm not saying that real time isn't a thing, right? Like there's still a need for real time. But when you think about what the CEO really wants, what they want is this knob that they can dial to get the data freshness that they need. And when they dial that knob, there's some sort of way for them to see what the cost is. Okay, I'm willing to spend a little bit more money now because I want to be able to see data every minute instead of every hour, right? So why does that matter? Why would we need to do this? Number one, maybe we want to reduce the risk of decisions on bad data, right? Data staleness, this is a classic problem in data warehousing. This is where we start to think about we should be good. This is where we start to think about data quality, right? So, obviously data quality is important. Most people care about data quality. It's like this kind of fuzzy thing when you really start to solve data quality. Is it about, does the data accurately represent the real world? Well, the data can be really accurate, but if it's representing the world a week ago and not right now, it's just as good as inaccurate data, right? So data freshness is actually a form of data quality. And when we have a write time system, what we're going to do is we're going to dial that knob up to a minute right before we want to make an important decision based on some dashboard or report. Because otherwise, we can put together like the best ETL platform in the world, but the executives aren't actually going to use it to make any decisions. So we now have that sort of hidden sunken cost problem. The second example is actually the exact same as the stale data problem, but let's apply it to machine learning, right? So we already talked about the TikTok example, like a real-time recommender that's going to adjust to new trends in the world. Another example is forecasting, right? So when COVID hit, all of a sudden the forecasting models that were looking at house prices or Clorox wipes, for example, those no longer worked, right? We can look at the features. There's some anomalies in the features. That's implying a concept drift, right? So there's a change in the relationship between the features and the labels, right? Another example is fraud detection, too, which we're going to talk about in a bit. And that's actually the same thing as the problem with the reports, right? We need to be able to detect the concept drift, and then we need to retrain the model, put it back into production and response. And that's when we start thinking about this sort of buzzword idea of real-time machine learning. That's when we start to make it a reality, right? Next is improving agility, right? So we already gave the example of the CEO who wanted to be able to move things into the curbside pickup system. A lot of times when I'm working with customers at Databricks, and we say, oh, maybe you need streaming, for example. And then the customer looks at me and says, well, yeah, streaming, that's this cool idea, but we don't actually have any real-time use cases today. We have a whole bunch of real-time use cases a year from now, but we don't need anything right now. So we're not going to actually build for that for now, right? But then what you end up happening is you talk to them a year later and you say, okay, now we actually have all these real-time use cases we want to put into production, but we can't do it because we chose a very batch-centric architecture. So agility is that ability to dial the knob without actually having to physically move data, without having to refactor code, and without having to change platforms. And then finally is cost predictability, right? A lot of times people think streaming and they subconsciously think it's on 24/7, so it's going to be expensive, so it's probably not worth it. And we're going to talk a little bit about streaming versus incrementalism in a little bit, but just appreciate the fact that when we're processing data incrementally, there's actually less reprocessing, which you get in batch. And in some cases, that can actually reduce the cost, and it can actually make the cost more predictable because you're not doing as much auto-scaling. All right, so for the rest of the talk, I've got about 20 more minutes, and we're going to be talking through the 4 steps that you can use to actually put this right-time architecture into production. So far, I've given you some fancy ideas, but let's actually talk about what that looks like. So the first step is deciding what a right-time use case even looks like in your company, right? And this is a list. I actually went to all of the different industry vertical leads at Databricks, and I told them this idea about right-time processing. And I asked them what kind of use cases where a business might say, hey, I want maybe an hour latency, maybe a day latency now, but I want to be able to dial that knob to get minutes very quickly in the future. And it was actually surprising that all sorts of different use cases. Every single use case you see here is an example where there's some sort of reason why you need to be able to process data fast and slow without having to pivot between different platforms. Okay? And if you're interested, we can have a conversation. I don't have time to dive into like how that actually looks, but we can also talk with the industry leads and talk about that in more detail after as well. Next thing you'll notice is at the bottom, I actually put together a list of the data sources that you actually use to power those use cases. Okay, and those are what I think of as right-time data sources. Which brings me to my next point, and this is, I think, one of the most important takeaways, I hope, if you forget everything else, because you're about to go listen to a million keynote sessions around LLMs and all the other stuff going on. If you forget everything else, this is one of the most important things, which is this idea that when you're prioritizing right-time use cases, you want to start with the data source. Okay, and that's obvious, and people kind of roll their eyes. It's this idea that, best case freshness cannot exceed availability, right? So if I have a fraud detection algorithm, and then that needs to be running every second, and my web clickstream data doesn't get given to me until the end of the night in my S3 bucket, well, I can't really use that. And you're like, well, Dillon, that's obvious. We all know that. That's just, a fact of physics. But I can't tell you how many times what happens is someone, fires up a Jupyter notebook or a Databricks notebook, and they put together a really great fraud detection algorithm that works based on the historical data that they have, but then the project gets delayed because there's no way to get that data incrementally, right, every second. What you have to do first is you have to go to the data applications team, ask them, hey, are you comfortable setting up a Kafka topic? Because sometimes that sits outside of our team, as the analytics team. We actually have to work upstream. Maybe that's the ERP team that's managing like the SAP environment. Maybe it's like the applications team. Work with them, hey, can you set up a Kafka queue? Here's what we need to actually do this. And then start modeling, then start putting it together. So that's actually, obviously you have to prioritize based on business value too. But if you forget about the data, you're going to start running into issues where projects take a lot longer and you say, oh, I don't know why this project's getting on hold. Well, that's actually why. So what I recommend is you look at the data availability. What's the best case, what's the worst case? And then what's the best and worst case data freshness that I need? But then also look at the data characteristics, right? Is it append only? If there's changes, are we able to set up a change data system, or do we have to do snapshot replication? Is it going to be SED type 2? Right, these are all questions we need to ask up front. And right, if you come from like a data engineering or like a data warehousing background, a lot of this is kind of obvious. But it's even more the case when we start thinking about streaming and the ability to dial it up. Right? So I'm going to give one quick example of one of my favorite real-time machine learning use cases, which is fraud detection. Okay, so going back to e-commerce, so I actually do a lot of work with retailers. E-commerce is a really important thing. One of the trends that we're seeing right now in fraud detection is that there's more false negatives and there's more false positives, right? So more people are getting away with fraud. 3% of the world's e-commerce transactions are fraudulent, right? There's a lot of fraudsters out there, and they're making a lot of transactions. But there's also more false positives, right? So people are getting their credit card blocked. They can't make purchases they want to. Everyone's nodding their heads because you've all tried to buy something. And then you're saying, oh, I'm just going to not use this. I'm not going to use this vendor anymore because they keep blocking me. And that's a really big problem for retailers. So if you even want to get into the e-commerce business, you have to put, on average, 10% of your revenue goes towards just fixing fraud detection, right? So 10% to fraud detection has table stakes. That's pretty big, right? The reason why fraud detection is a really interesting right-time use case is the adversarial nature, right? You're always playing this cat and mouse game. And this is also, by the way, the same case with cybersecurity and network intrusion detection when you're doing like anomaly detection in a network. These are some really fun kinds of exciting things because as soon as you figure out how to stop the bad guys are going to see that that your model doesn't work, that your model's stopping them, and then they're going to find a new hack or they're going to find a new fraud technique. Right? And so this is actually a concept drift problem, right? We don't usually know if there's real concept drift because we don't always have the labels, and so what we have to do is find outliers in the features, and then we have to use that to infer concept drift, and then there's all sorts of techniques. If you're interested to learn more about those techniques, my friend Avi and I, like I said, we have another talk where we get deeper into this, but there's all sorts of different things, where deciding when and how much human in the loop there is to actually change that model, reproductionize it, do adaptive learning, like all sorts of different things. But what's interesting about fraud detection is you can't take the model out of production because now you're not making any money. And so you have to not only figure out when the fraudster's found a new technique, but you have to immediately detect it, right? And as soon as you see that, you have to do a batch retraining, put the model back into production, okay? So what does this actually look like? Well, it actually looks like, hey, there's some batch areas. The training part is batch, right, when I'm retraining the model. But the part that's happening in production, where all the orders are coming in and we're trying to stop the fraudsters, that looks like a stream, right? And so my feature engineering pipeline for training is batch, but my exact same feature engineering pipeline for production is streaming. Wait a second, that's actually a huge source of errors and bugs, right? If you actually talk to a lot of machine learning engineers, they say one of the biggest problems is finding these bugs where they put it into production, and when they bring it back to retrain in response to concept drift, the features aren't the same. So that actually looks like a write time problem, right? All the data is getting put into production, it's getting monitored. So now we're actually using this idea of write time to address data quality, right? Because data quality is like a concept drift is a version of data quality. So now we're looking at, okay, we need the ability to process data fast and slow to be able to reply to that data quality problem. All right, step 2. I talked about streaming a lot. I talked about incrementalism and all these things. Let's talk a little bit about what streaming is. And for a second, let's forget our preconceived notions. I'm going to actually try and explain streaming without using the word batch and without using the word latency. So let's not get trapped in semantics on this. When you actually look at the official literature and Databricks documentation and you look at all the different streaming tools out there, you hear this idea of unbounded, right? So streaming is about unbounded processing. It doesn't even mean that it has to be fast, right? In a bounded world, right, so in a typical relational database or in a SQL query, If we're performing a stateful operation, like a join or a window or an aggregation, we see all of the data as it's happening, right? And so it's pretty easy to reason about. Now, in an unbounded world, if we're doing a stateful process like a join or an aggregation or a window or a filter or anything, we never know for sure if there's data that we haven't seen yet. So there might be missing data, there might be out of order data, there might be late arriving data. And what a streaming framework really gives you is the tools in your toolkit to be able to deal with this problem of unboundedness, okay? If we're able to deal with the problem of unboundedness, that affords us the ability to have strong reliability guarantees when we're incrementally processing, and as an end result, we can get a lower bound of latency, right? So it gives you things like watermarks, right? Watermarks, when are essentially a way to deal with that unbounded nature when you're doing stateful transformations. If you're interested more in this, I'm kind of actually keeping this a little bit high level, but we're going to do actually a general session tomorrow with Michael Armbrust, where we'll walk through that in a lot more detail. But just appreciate, we take it for granted. We take ACID transactions, we take referential integrity for granted because we're usually working in a bounded world, and we figured out how to do that in databases multiple decades ago. But it's actually really hard to do in an unbounded world, especially when it's a distributed system. Right, so streaming actually gives you this thing called exactly once guarantees, which is this fault tolerance that makes it so much easier to deal with that, okay? So it's not only for low latency, right? I can actually do this thing in Spark structured streaming, and if you've used Spark before, and this is like kind of obvious to you right now, but you're saying, what is trigger available now? Trigger available now is the new version of trigger once. So trigger once is actually deprecated if you come from Spark structured streaming background. Trigger once is deprecated. Available now, I like the name better personally, but it also actually adds a lot of new capabilities. And if you're new to Spark, you're new to structured streaming, what available now does is it says, hey, I want you to wake up. I want you to look at all the new data that you haven't seen yet. I want you to do that exactly once fault tolerance that you do so well, like all that really hard stuff that I don't want to have to deal with. And then I want you to go back to sleep until I tell you to wake up again. So now I can be doing streaming, but I might only actually process the data once an hour, maybe even once a day, right? I actually have customers that are doing streaming, but their data freshness is 1 week, right? So now we're decoupling streaming and latency, right? And now you understand streaming and batch, they're kind of two sides of the same coin. So is that batch? There's actually, like, it's kind of a question of semantics. And at least hopefully there's some consistency in how you're thinking about these in your companies, what matters. When I'm ready to dial that knob, and I want to start getting into minutes or seconds or maybe even sub-seconds, what I do is I change that trigger available now to what we call a processing time trigger. So on the left-hand side, the way I dial the knob is through my scheduling rules. So maybe Airflow or Databricks workflow, I'm saying processes every hour, wake it up every 5 hours, whatever it is. When I want to start getting, usually the cutoff for using processing time is around a minute, but that's also highly dependent on your data volume. But now what I'm doing is I'm dialing the knob by parameterizing the function, right? So this is, in Databricks, this is going to sit in a notebook. You're going to have a notebook parameter in there, and that's going to be tuned in the job parameter. And that's going to determine, if you're new to streaming, what that's doing is the trigger is saying when to start a new micro batch. Trigger available now says, give me one big micro batch as soon as you turn on, and when you're finished, go to sleep till I tell you to wake up again. That's usually coming from Airflow or my Databricks workflow or whatever it is. And then with processing time trigger, I say, hey, I want you to just keep the cluster going, and then cut off a new micro batch every 2 seconds. Right? And we can start to get into milliseconds. There's another project called Project Lightspeed. We are going to be talking about it tomorrow in the general session. And that's also going to be how we can actually dial that knob sub-second. Okay? So what we're going to do is we're going to use that capability to build a right-time architecture. So this is sort of an older, this is what we call a Lambda architecture. It's about 13 years old, okay? And in the Hadoop days, Apache Storm was kind of one of like the early event time processing frameworks. And what we used to say is, well, streaming is kind of unreliable. We haven't figured out all the stateful processing, hard stuff, and watermarks. And so what we're going to do is we're going to process all of the data twice. So I want data fast and slow. I want right-time processing. But I have 2 different tools. And obviously, this didn't last very long because now you have to deal with maintaining 2 separate systems. Sometimes there's different data coming from the batch. So batch is usually like MapReduce, and then fast was usually Apache Storm. And they might actually have different results at the end. Okay, so this is called a Lambda architecture, and there's a ton of writing, like Jay Cripps, for example, the person who created Kafka, has a great piece talking about some of the limitations here. So nowadays, what you usually see is something like this. Okay, Where with Spark, you have one framework that supports both batch and streaming. And then within streaming, we have the trigger available now type streaming and the trigger processing time streaming. And now you're like, wait, I thought you said batch. OK, now I'm actually overloading the word batch. I'm actually guilty of overloading because batch is when we're saying it's bounded, right? So Spark does bounded, and it does unbounded. And within unbounded, we can do fast and slow by choosing between available now and processing time. So Sparks, it's a single API. You don't have to physically change data. And then now what about Delta, right? Are we going to talk about Lakehouse and why, why is this important? Well, ACID, you hear ACID thrown around a lot. Oh, we need ACID. So S3 is eventually consistent. It's really cheap. It's really scalable, but it's eventually consistent. What ACID is this thing. We've already been able to do it in relational databases for a really long time. But what it gives you in this write time architecture is the ability to unify batch and streaming reads and writes. It gives, so when we talk about ACID, it's actually the I in ACID. This is kind of nerdy, but the I is my favorite out of all of them. I think it's good. The I is my favorite. It stands for isolation. And isolation is the ability that when I'm running a batch query from the data storage, and streaming data is coming in like every second. Like I have my processing time down to 1 second. But I want to have a batch query. I want that batch to have a consistent view of the table. That's query isolation. So Delta supports that, and that's actually how we unify streaming and batch. Okay, so when you go back to the fraud detection thing, right? Data's happening in production. All of a sudden, the fraudsters start hacking us or causing all this new fraud. We have to retrain the model because we have our monitoring and our anomaly detection set up right. And now we want to take the production data, but we need to do a batch query off the production data so we can retrain the model. Delta and ACID and isolation and all these fancy things makes it so we don't have to duplicate the data. Right? Before Lakehouse formats, you had to duplicate the data, right? Relational database data warehouse can't really do streaming. It can't deal with that lower latency bound. S3 is really good at that. It's cheap and scalable, but you need ACID to be able to do this thing where you're doing streaming and batch, right? So Spark unifies batch and streaming at the API layer, at the compute layer, and then Delta and Lakehouse unifies batch and streaming at the storage layer, all right? Just to wrap things up, the final step of the 4-step process to get to write time is using Delta live tables to simplify. Okay? What is DLT for short? DLT is when I say, I want to take advantage of all of those things that you just said, Dillon. Sounds like Spark is a great option. Sounds like Lakehouse is important. Even if I'm not doing streaming, even if I don't need all these special things, it still sounds like Spark and Delta are going to be really valuable to me. But I don't really want to deal with all those things, right? Data engineering is pretty hard, right? I still have to think about how do I get my merges right? How do I incrementally change data? What about checkpointing? What about watermarks? What about dependencies? All those things we still have to worry about. So what Delta Live Tables gives you is an abstraction layer around all of those things. So Delta Live Tables, it'll automatically manage the infrastructure for you. And you're gonna declare specific flows between different data sets, and then it's gonna go into the Delta layer, the Spark structured streaming layer, and figure out the right way to do all that. So fun fact, the engineer who created Delta Lake was the same person who created structured streaming, and he's also the same person that created Delta Live Tables. So it all works together in this really nice way. His name's Michael Armbrust. He's giving a general session tomorrow and a keynote on Thursday, so definitely check it out. And he's going to be talking about some really exciting announcements that we have around Delta Live Tables that's actually going to make it even easier to do incremental updates. And incremental updates is actually core to the write time architecture. Everything we've actually talked about so far has actually been about how do I incrementally process data? How do I reduce reprocessing? How do I choose the right strategy to update data? That's actually what it's all about. Cool. So just to summarize, step 1 was about prioritizing the right use case. It was about starting with the data in mind, right? Data-centric use case planning. Step 2 was about streaming, bringing in streaming, even if you don't need milliseconds, even if you're not a hedge fund and you're trying to get your Ethernet cable shorter, streaming is still useful, right? Step 3 was around